Hello and welcome to Project Poseidon. In this video I'll take apart Fujifilm GFX 100 Mark II and hopefully we can take a look what's wrong inside and attempt a repair. This camera was submerged in water and get some parts corroded, so right now it doesn't turn on, it does not do anything, and sometimes there is information shown on the front display, but that's about it. This GFX Mark II is a flagship medium format camera featuring 102 megapixel sensor. Even today, after 2 years since its release in 2023, GFX bodies from Fujifilm, like this one, can deliver impressive image quality and usually used in extensive and expensive production level environments and artists all around the world. So it makes a little bit of sense to try to repair this camera instead of sending it to the landfill. As an electronics design engineer, I am eager to dig into this camera internals to learn something new. Perhaps with gained knowledge we could even have a chance to repair it. First we need to remove all the grips so we can access all the screws on the exterior of the body. Then we will need to remove all the visible screws, and hopefully after removing outer metalwork, I'll be able to investigate internal conditions of various blocks and we will see how much damage there is to fix. I knew from exterior inspection that there was water ingress and probably some damage to sensitive electronics internally. So it could be quite a challenging project with probably very slim chances of positive outcome and success. I also apologize for obstruction of the view with my head. This was my new setup and I didn't quite get all the angles and perspectives just yet. Sorry about that. This video process is sped up a few times, so we are not wasting too much time looking at the boring parts. Feel free to slow down or pause at any time to get some details, or also ask for the photos of particular step. To my current knowledge, this is the first disassembly of latest GFX 100 Mark II camera published online, so enjoy the show. This video is a part of the larger article worklog published on xdevs.com site, currently available in repair section. There are a lot of photographs showing overall step-by-step disassembly process as well as repair. Hopefully this can be useful for somebody in future. At this point, the chances of successful repair are pretty slim because from my experience in the past, water-damaged electronics is quite difficult to troubleshoot, and also if there are any custom proprietary parts damaged too much, then we will not be able to get a replacement part, and that would be the end of this project essentially. At this stage, I'm removing the rear panel, which includes the main LCD and control buttons. Need to proceed carefully here and avoid pulling it too far, as there are delicate FPC flex cables connecting electronics to the rear LCD panel. Next, I remove the bottom plate to access internal components of the camera. At this point, it becomes clear that this repair may not be possible. There is a significant corrosion along the lower section of the main PCB, with some components either burned or rusted near the central area where the white flex cable connects. At this stage, I decided to take high-resolution photos of the as-found condition, both to document the original state in case any components come loose during cleaning, and also to serve as a reference for reconnecting the cables and parts later, in case we will get to a point when this camera would be salvageable. I've used a long exposure technique with another camera mounted on a tripod, manually painting the scene with LED light to eliminate shadows and reflections. Most of the photos you see on XDev's website are captured using exactly this method. Now let's continue with disassembly. So first I need to disconnect all the flex cables, inspect the damaged parts, and as well as investigate what can be repaired and what work needs to be done to get it to a better condition. There is also a flex assembly on the bottom section that is designed for expansion grip that GFX 102 supports. So that grip have some electrical connections for battery power and also for wireless transmit function. Main cable with 4 thick lines was designed for power, and it was soldered into the main board. So that's what I just removed. Next, I've decided to remove SD card, CF card compartment. And for that, I'll need to disassemble a camera a little bit more and release a couple more screws, as well as top frame where the OLED with the top controls is. So since I was disassembling this camera the first time on this video, it took me a little bit of fiddling and wiggling the bits around. I didn't want to pull anything too hard to avoid damaging. Overall, this camera was built rather conveniently for disassembly and repair purposes, because all the screws are rather conveniently located, and as well as they are just using Phillips standard size. So I would say this is probably at level 7 out of 10 for access and repairability, even without manufacturer service documentation or any really guideline in terms of how everything is attached. I was able to figure out the best way to disassemble the camera, as well as put back together without actually damaging any additional parts or fragile electronic bits. This is also a very similar design to that Fujifilm used in older cameras such as GFX 100S, GFX 50S, as well as older GFX 100. And in fact, many of the parts or even connectors are used from their mainstream X series cameras such as XT5, XT4, and similar age bodies. For example, main processor that Fujifilm implemented in GFX 100 Mark II was already used in XT5, which was released a year earlier. Of course, some of the parts are unique to GFX 102, such as Gigabit Ethernet port, magnetics for which you can spot in the corner, visible with a time mark label on the top. Now, when removing the PCB, you need to be careful because there is a flex cable connected on the back. That cable goes to the shutter assembly to control the release and shutter operation. Now that we have the PCB out, I could inspect the sensor assembly, and it had some corrosion in the corners, so unfortunately I'll have to take the sensor out of the body and clean it some more. Here are some as received images of all the mayhem that is happening on the main board. A lot of work needs to be done to clean this up, and all the high resolution photos reveal extent of the damages from simple liquid water ingress. So a lot of careful scraping will be required, as well as some cleaning. And the same goes to the main body, especially the bayonet mount. You could see a lot of corrosion for the alloy. So this looks like a flaking salts or some kind of corrosion like that. Everything as camera was disassembled at this point. Sensor was still attached to the body, but everything else was out. And this is the main tool that I use to clean all the metal parts as much as possible. So this was mounted on Proxon Dremel-like tool. And finally, after some swearing and cleaning, this is the best I could get the main body. This is the front part. Other than heavy pitting, it doesn't look that bad in the end. And here is some microscope footage I recorded during the disassembly. I go over the main parts of GFX mainboard here. Most of the board is actually very clean, giving me some hope that it could be just a few localized areas that could be repaired. In this area, this blue chip is an audio codec for microphone and audio outputs, as well as some DCDC regulators and some MOSFETs for power management. Here are some corroded passives near the USB-C connector, as well as the FPC connector for that expansion port. And here is the LCD connector. This is a FPC cable connector with 0.2 millimeter pitch. Some of the pins in the corner were quite damaged and corroded, so I needed to replace that connector. And this is the main area where all that mayhem and corrosion was happening. So I already replaced in this video TPS 63070 regulator. It was giving out 5 volts. As well as I've replaced all these FPC cables in this area and some of the passives over there. This is the main memory that is populated on top of the Fujifilm processor. Up there we have some more regulators, and there was a little damage that I've caused during the disassembly, so that little jump wire I had to put back with repairing of some of damage I caused myself. And there is some more regulators as well. All these squiggly lines go into the interface cable connector for SD card and for the CF Express. Some more regulators, and this is the main connector for sensor data. So this is 8-lane SORDES connector, as well with some feedback for IBIS stabilization coils. This connector on the right is actually unused and not connected to anything internally, so later I've just desoldered it because it was corroded and I didn't want to leave it there, probably causing some leakages or some other issues. Memory card interface board had a little bit of corrosion on the down there on the bottom, but all the main like CF Express pins and SD card data pins were okay, so I just left as it is after a little bit of cleaning. And I'm back to the main board, showing some of the capacitors. Overall, this board wasn't damaged too horribly, so hopefully after those cleaning processes and replacing FPC connectors, we could actually have a good confidence that it may work. And here is my attempt to show the package-on-package assembly. Also, FPC needed some repairs in different areas. So I had to repair pins that were corroded on main sensor assembly, as well as LCD FPC and the FPC on the top module with OLED and on-off switch, because one of the buttons was not working, as well as rear knob. So there was 3 lines that were corroded out and disconnected, so I had to put a little jump wires on the FPC cable using very fine 0.2 millimeter pitch soldering tip, and a lot of holding the breath during assembly. Capacitors replaced near this TPS 3070 regulator were 22 microfarad 0805 size. So original were used as a soft termination type. You could see actually a couple of them sitting over there with the little legs to decouple them from main board. This probably was done for better mechanical reliability of the assembly. I couldn't find the exact replacement for such type capacitors, so instead I just populated with the standard soft termination caps I've acquired from DigiKey. The BOM parts list of all the connectors replaced and all the other parts is available on xdevs.com article about this camera repair. Most of the other flexes were actually in quite good shape, so that was a relief, so I didn't need to disassemble and repair much more flexes, because that was not an easy task. And here is some corrosion that I was mentioning earlier about SDXC card slot. So this is just the card detection, so I cleaned it a little bit after this video, and I think that is not such a critical area to be worried much about. Here you can see all the magnesium body alloy corrosion. So they look like white flakes with different colors. So I had to apply quite a bit of force to clean all that out. And obviously I tried to remove all the electronic bits as far as possible to avoid spreading the dust all over the stuff, especially the sensor assembly. That was quite a challenging task, as I didn't want to remove the sensor originally to avoid alignment issues. I apologize about shaking and messing with the video much because it was rather difficult to handheld the camera while looking through the microscope screen. And here is the look on the mainboard PCB from the back, the side that you see when you remove the LCD assembly from the rear of the camera. So we can see all the components there, and as well as removed regulator at this stage in the damaged area in the center down bottom. The area covered by copper looking heatsink or cover, that is the main DCDC regulator that converts most of the power from the battery supply to the rest of the regulator on board of this body. And here is the back of the same PCB. You could see a large chip top left corner. That is a memory chip for a buffer, most likely for Ethernet data storage, as well as Ethernet controller. A little chip in the center bottom with RW265. That's the little chip. RW265 is a main flash memory that contains the firmware of the camera. And DCDC regulators you can see under it. Those are responsible for powering a lens attached to the camera, as well as additional focusing motors and things like that. Here is the close-up on the damaged part of the DCDC regulator section. Overall looks pretty good, and I resoldered the new parts back into the place like it's supposed to be. And here I'm back to assembling the top section where the flex for buttons and knobs was damaged. So I had to excavate some of the bits to get access to the proper pin so I could repair it. I was doing all this by myself, so unfortunately I didn't have a camera operator to keep everything in focus and document every single bit. It was supposed to be a rather quick project instead of turning into multiple weeks or multiple months saga. And finally I had to remove the sensor block for extra cleaning. So I tried to mark all the spacers in the spots they were originally. And here are all the nasty areas I had to clean up as carefully as possible to avoid contaminating other stuff nearby. So looks pretty bad, but actually it cleaned up all right, and I was confident enough to reassemble everything together after maybe a couple hours of cleaning. And here is sped up version of these couple hours to show various angles and steps taken during sensor disassembly, cleaning and reassembly. I was reluctant to dig this deep into a sensor module since proper alignment and flatness is probably very important for accuracy of the focusing and image quality. But eventually decision to go ahead was made because leaving all the nasty corrosion bits so close to the sensor was not a great idea for the field use of the camera. Plus I had no idea if there was any more electronics damage from liquid deeper in the sensor block as well. GFX 100 Mark II is using same sensor as newer GFX 100S Mark II, but I couldn't get deep enough to see actual part number on the sensor body. Old GFX 100 used Sony manufactured IMX 495, which is a customized version of Sony IMX 461 ACQ with PDEF pixels. Sadly, I couldn't get any information online about what specific sensor newer GFX 100 Mark II is using. Sensor assembly has 5 flat flexible PCB cable interfaces going to the main board from the electronic perspective. So there is a 5 contact FPC BIS TH cable for some kind of position sensor perhaps. Then there is 23 contact cable with coils drive for IBIS movement mechanism, and also some pins for ultrasound actuator for dust cleaning feature. There is also many contact cable section with 1.5 volt VDD supply for sensor core, thick 2 lines you could see in the center of the flex. There is also a 51 contact cable section with additional power and control signals for sensor electronics and readout, and as well as main 51 contact 0.2 mm pitch FPC cable marked FPC COM-SIG, and has some part numbers like SW18 and SS15153. This FPC is a main interface with high-speed 8-lane serial link for sensor data readout and perhaps some auxiliary I/O for IBIS stabilization coils. I have measured coils with my Keithley 2002 DMM, and they show resistance around 122 ohms, 160 ohms, and 230 ohms. They are driven by electronics in normal mode with a 170 kHz square wave with a peak-to-peak signal around 5 volts. So movement is achieved by variation of duty cycle in the PWM coils, and these coils are driven by a pair of 4 amps half-bridge Toshiba TC78H653 drivers, which are populated on the main board near the FPC connector for IBIS mechanism. Each of these drivers is responsible for 2 coils, so we have essentially 2 drivers to share the 6-coil mechanism. Sensor also have the front color filter that is designed to reject infrared and UV light from reaching the sensor element, because actually most of the CMOS sensors, they have wider sensitivity range than the typical visible light spectrum. So to avoid wrong color reproduction, a lot of camera vendors put in infrared and UV filters right in front of the sensor to improve the color rendition. This is actually quite a problem for scientific applications, so a lot of customers who are using regular cameras for scientific purposes actually converting their cameras into a wider spectrum type by removing this filter in front. This conversion could be achieved by removing the steel bracket that holds infrared ultraviolet filter in place and replacing it with a wider transmission glass cover. Be careful during this conversion, as original filter also has ultrasound emitter to help dust off smart particles from the surface. I'll be converting one of my older cameras and perhaps will make an article with the results later on. So let me know in the comments if you want to learn more about that. Infrared photography could be quite interesting and often has unique look of the daily world scenes. And for reassembly, I've just repeated everything back in the same order, just in the reverse. So put all the bearing balls, put all the magnets back in, and all the springs. So it was not that difficult, but a little bit nervous. I've had a broken 63 2.8 lens attached to the body, just for easier movement and easier alignment of the camera, so I was not really doing anything other than helping with the orientation and position. To reassemble the camera with the new cleaned parts and everything in nice shape and condition. So hopefully we can get some progress and see this camera working again afterwards. So this is not the best angle, but hopefully you can see all the main steps like attaching the cables and putting all the screws back in. Jumping a bit ahead, camera didn't work properly after first dozen of assembly attempts. That was due to still bad connections at the main sensor FPC, where some signals were still not making contact between flex cable and mainboard. This issue caused the sensor to move to extreme side position, and camera was getting very upset, saying error, turn off camera and try again, while blocking all the controls so I couldn't try different settings. Other issue was with corroded out 68 ohm resistors for lens communication FPC. So when GF lens was attached, camera was just power cycling itself every second and didn't want to operate properly. I've ordered new 0402 resistors from DigiKey and replaced the connector once again, so that resolved the lens problems. There were a couple of the minor issues with the missing connections on keypad for the top controls, but like I said earlier, that was easy to resolve and was just a simple fix with the jump wires. Total, I've probably spent maybe 80 to 100 hours here and there with all the learning and troubleshooting steps. So I've took a lot of different pictures and notes in the process, and hopefully that will be useful for some other Fujifilm gear repairs that might be coming soon as well. Last but not least, I've disassembled, cleaned and reassembled rear panel with main LCD and rear controls for this camera. This was rather simple and not much interesting stuff, so I did it off camera. Overall, this whole project took about a month of time, doing it on occasional free evenings. I'll need to get some proper sealant strips in future to reseal all the metalwork body pieces and to make this poor Poseidon camera more resistant to water ingress in the future. For now, I'm just applying some double tape around the most sensitive parts just to keep some kind of seal in there, while I'll be doing some testing and verifying of the functionality of the camera until I'm sure that everything is working 100%. Then I'll take it apart again and see if we can make it permanently sealed. And to my surprise, camera actually worked afterwards. Here are some sample images that I've captured after repair on the first week. Not too bad after dead on arrival camera and a month of experiments and testing different parts and bits. Thank you for watching, and until the next time, take care.